Hi everyone, welcome to this tutorial on how to do 14.8 number 3. We're going to talk about how to do Lagrange multipliers. So as we can see, the question asks us to use Lagrange multipliers to find the extreme values of this function f that's defined as x squared minus y squared, and it's subject to this constraint x squared plus y squared equals 1. And we can think of that as some function g of xy, and setting that equal to 1 is going to be a level curve of g. So now that we have these two functions, we can set up our Lagrange multipliers equations. So that's going to look like the gradient of f is equal to lambda gradient g. If we expand this out, we get the gradient of f, as a reminder, is the partial of f with respect to x and partial of f with respect to y. So if we look here, partial x is going to be 2x and partial y is going to be negative 2y. And that's going to equal lambda times the entire gradient g, which is 2x, 2y. It's a little easier to work with them as separate equations, so I'm going to bring out the x terms like this, and then the y terms I'm going to put over here. So it's negative 2y equals lambda 2y. Oops. Now, there's usually two ways you can go about this. You can either solve for x and y and plug them into the constraint, or you can solve for lambda and then plug the lambda you found into the other equation. So if I solve for this lambda, I would plug it into here. For this problem, it's not really necessary to go through those separate steps. So I'm just gonna kind of look at the obvious, which is here you could say lambda equals 1 if you divide both sides by 2x, or x equals 0. So I'm just going to put a little or there just to remind me. And it's kind of the same thing for the y equation. So we can kind of obviously see that lambda can equal negative 1 or y can equal 0. Now, we have all these possibilities, so we're going to have to check which ones can be true. So I'm going to number these. This is 1, 2, 3, and 4. So possibility 1, if lambda equals 1, then lambda has to equal 1 for both the x partials and the y partials. So since we already proved that, the x partial is true if lambda equals 1, we have to check the y partials. So is it true if negative 2y equals 1 times 2y? No. Therefore, this doesn't work. If we check the second possibility, if x equals 0, then we can use our constraint to check how this can be true. So if x equals 0, then we get y squared equals 1, and so y can equal plus or minus 1. That means our critical points would be 0, negative 1, or 0, 1. Cool. If we check possibility 3, we have to make sure that lambda equals -1 for both lambda equations. So we already checked the y equations, let's check the x's. So 2x equals -2x. This is not true. Usually it's only true if x is 0, which we already checked. So we're gonna say this is not something we're gonna deal with. For possibility 4, if y equals 0, then we look at our constraint g and we plug y equals 0 into that. So we get x squared equals 1, and if we square root both sides, we get x equals plus or minus 1. So the critical points would be -1, 0, or 1, 0. Cool. So it looks like we have 4 critical points to check. So that's all the critical points that we need to find, since the other possibilities didn't yield any critical points. So now we're going to evaluate f at each of these points and see which ones are maximums and which ones are minimums. So let's do f of 0, -1. That's going to be -1 squared, which equals -1. F of 0, 1 is -1 squared, which also equals -1. For f -1, 0, we get -1 squared, which equals 1. And then f of 1, 0 equals 1 squared, which also equals 1. So our final answer is that we have a maximum of f of -1, 0, which equals f of 1, 0, which equals 1. And then our minimums are f of 0, -1, which equals f of 0, 1, which equals -1. And this is a valid way to format your final answer. Hope this helped.